Video, we're going to look at solving radical equations. We have an example here. When we have a square root, we have the radical, okay? We want to do the opposite. The opposite of the square root is squaring, okay? The opposite of the square root, we can undo that. Just like if we see this plus, you tend to want to go to doing -5, right? Because subtraction is the opposite of addition. We can't do that yet because it's all underneath the square root. So what we need to do first is square both sides, okay? So when I square this side, it's going to cancel out the radical and leave me with just a regular x plus 5, okay? But that means I also, or what you do to one side, I have to do the other side. So this is my equal sign. I'm going to have to square my 8, okay? If you don't know what 8 squared is, we can come over to our Desmos calculator and you can just type it in. 8 squared is 64. So equals 64. And now we can solve the equation. X plus 5, I want to do the opposite. -5 minus 5. So x is equal to 64 minus 5, which again, if you need your calculator, is 59. And that is your solution. Okay, so you have to do this first. If it's all under the square root, you need to square both sides first. Let's look at another one. If we notice here, the difference is that this -3 is not under the square root. So we have to start with undoing this 3 first, and then we can square both sides. So in this case, I'm going to add 3 first because it's not underneath the square root. So I get the square root of x is equal to 4 plus 3 is 7. And then I'm going to square both sides. I'll change my color here. Squaring this cancels and gives me x, but I have to square this side. 7 squared is 49. Okay, and again, there's your solution. So these really shouldn't take too long. It really taps into your already understanding of solving equations. It just adds in another opposite operation. Just like addition is the opposite of subtraction, squaring is the opposite of the square root and kind of releases it. But I don't just have x equals 7. X is actually equal to 49 because we had to square this other side. All right, let's take a look at our next example. In this one, we can see that we have 3 square root of x minus 5 equals -2. So just like the other one that didn't have everything under the square root, I am going to add 5 to both sides. Okay, go ahead and add 5 to both sides. -5 plus 5 will cancel. And I have 3 square root of x is equal to -2 plus 5 is going to give me 3. And now I'm going to treat this just like if this said 3x, we would divide both sides by 3, which is what I'm going to do here. Okay, same thing. 3 divided by 3 will cancel, but you still have the square root of x. You don't have regular x yet. 3 divided by 3 is 1. And now when you have 1, it is a little silly to square both sides because 1 squared is going to be 1, but let's still do the steps here. Square root of x squared, I can cancel those out. X equals 1 squared is going to be just 1. 1 times 1 just gives me 1. Okay, so it's similar to all the same steps you're used to, except for that squaring of both sides at the end. Or that could be an earlier step, depending on what the problem looks like. All right, again, we have a multi-step one here. I'm going to draw my line. I'm going to start similar to what I did before. I'm going to get rid of this 6. Plus 6, it's on the outside of the radical, so I'm going to do -6 from both sides. Okay, cancels. So I have 2 square root of x minus 4 equals 2. Okay, now this one, the -4 is under the square root. So I can't just add 4 to both sides. I have to do this division first. Divide both sides by 2. The order is going to matter here. Divide both sides by 2. So I have the square root of x minus 4 equals 2 divided by 2 is 1. Now I can square both sides. Okay, now I want to do that. That way I could get the 4 out. Okay, I can get the x minus 4 out. So that's gone. So I have x minus 4 equals 1 squared is 1. And my last step here is going to be add 4 to both sides. Okay. So then x is equal to 1 plus 4 is 5. Okay. So I could subtract the 6 here because it was not under the square root. Okay. Then I undid this multiplication using division to both sides. And then I was left with whenever you have just the square root on one side, that's when it's time to square both sides. That part can be a little bit confusing. All right, last example here. All right, you notice here that both sides have a square root. So when that happens, you get to do your squaring of both sides right away, because what happens is we can get both sides out of both of their square roots. And we have 3x minus 5 is equal to 2x plus 6. And now we can solve this equation normally. Hopefully you remember how to solve an equation like this. If not, let's go ahead and review. I have a 2x here. I'm going to go ahead and subtract 2x from both sides. I like to have my x's on the left. There's several ways you could start this problem. If you wanted to add 5 to both sides first, you could do that. But I like to get my x's over here first. 3x minus 2x is 1x minus 5 equals 6. I'm going to add 5 to both sides. So I have 1x equals 6 plus 5 is 11. You don't have to do this step because it's a 1. I'm just going to show it here so you can kind of see our last step would be to divide. But when you divide 11 divided by 1, you still get 11. X equals 11. All right, that's it for our lesson on solving radical equations. Go ahead and work on your delta math and come back to this video if you need any extra help.